In this video, I'm going to show you how to build an n8n workflow that automatically generates faceless TikTok shorts of tiny workers doing cool stuff, just like the one that you see on the screen right now. Those videos are very popular right now on TikTok. They are engaging, they are satisfying, and most of all, this is not a saturated niche right now, like point of view videos, and those videos still can get thousands or millions of views. So my goal today is to show you how to build this workflow right from the idea generation to creating images, videos, sound effects, and background music. I will also cover some parts that other tutorials do not cover, like how to generate images in the same style, how to make sure that your workflow runs smoothly, and also how to overcome technical limitations and handle rate limits. That is something that is also very important to make sure that our flow works. So if you are into content automation, or if you want to build a viral style content machine, you are in the right place. By the way, if we haven't met yet, my name is Nadia. I build AI-powered automations workflows like this one, especially for content and marketing teams. So if you don't want to build this workflow yourself, and if you have other ideas related to this, then there is a link in the description where you can book a free discovery call with me. Okay, let's start building. I've just run this workflow a couple of minutes ago, and let's see the video that this automation produced. And I will also turn on the sound. Okay, it's not perfect sometimes. Okay, you see the idea, and I will also leave a link to this video down in the description below. As you can see, all the scenes, all the images in this video are in the same style. It has background music, it has some sound effects for each scene specifically. It is also now saved in my supabase right here. This is the video that I have. So the whole idea was generated by this automation. I clicked test workflow, and it also runs every day at midnight. This is briefly how it works. We want to produce a full movie from the idea to the final ready to publish movie. For each scene, we need to generate an image, then we need to animate that image, then we need a sound effect. After that, we need to combine image and sound effect in one scene. We don't need an image anymore because we have our animated image. And then we apply background music to the whole scene, and that is basically how our movie is done. And this is the whole process in simple terms. So we generate ideas, we generate scene description with image, sound, and animation. After that, we get that scene with image, sound, and animation for each scene. And after that, we generate image and generate animation. Obviously, generating image should go before generating an animation, but generating a sound can be done in parallel to generating image and animation. And after we have all those scenes, and then we select the background music, we combine the scenes, and we compile a final video, and then we upload that final video to, in my case, I upload it to my supabase store, but you can even upload it to YouTube automatically or to other social media platforms automatically. Okay, let me go back and I will explain how it works. So first we generate an idea. We give our language model a task to come up with an idea for our whole movie. Also, I looked into many TikTok accounts. I found that the most engaging videos are the ones that display a process from start to finish, because as humans, we are drawn to know what happens next. So we want to see the whole process. Okay, here is how we create a node. When you start building this automation from scratch, you first add a node, and you'll have this as a trigger, and those two steps are triggers. First is trigger manually, and second is a scheduled trigger. Then we need to add another node, and this is an AI node. This is not an agent, this is a basic LLM chain. Then you can connect a new language model to it. I use this open router, and when you create it first time, you need to create new credentials and add your API key from open router. Let me go there and show you where to get it. So you are inside your open router. It gives you access to all of those different language models that exist. Some of them are free even, and you may even explore it, how to use free models. And then you go here to API keys, you create a new key, and then you connect it to this account when you add a new credential. And after that, you can pick a model right here. You can also add some parameters, and you specify the prompt right here. Let's just go back and I will show you what I have. I set up a system prompt for this specific node, and I explained that it is a creative director for a TikTok account, and that we will be generating short videos with a satisfying process, and I ask it to return it in a JSON format. This is also important, so I ask it to come up with first a couple of 10 ideas here, and then pick up a random process from those ideas. I found that it tends to always pick similar processes, so you might want to modify this prompt a little bit, or you might want to have a human in the loop, so human sees what the idea this language model selected, and if you want to move on with this idea, or if you want to pick another one. And we also instructed to provide 6 to 8 row steps. Our videos will be 5 seconds long, so 6 scenes will equal to 30 seconds video. From what I saw, videos that perform well tend to be somewhere in the range between 30 to 60 seconds. And so we instructed to return output in JSON format, and then I parse that JSON in the next module. This is a parse node, and this is manual mapping, and we just drag and drop the result from a previous module, this one. This is how you do it, text, and then you need to add this parse JSON. This is an internal function inside n8n. This is how you do it. So you parse JSON, and that parsed idea is here. You can see it on the right now that it came up with 10 ideas for what this movie can be about. It picked miniature clockwork toy assembly, and then here is 7 scenes with raw description and number. It is also important that we instructed to preserve numbers. We will need them later because we want all the scenes to be in the right order. There is another step that helps us to create a more detailed description for each scene. So how it works, again, it is a language model step. We connect open router, and this time I picked GPT-4o. From my internal testing, I discovered that GPT-4o produced the best description for our text, for our images. We obviously need to create text to image prompts on this step. And so I use GPT-4o with a high temperature to produce those scenes. And what we have here also is that I instructed, I have a system message, and in this system message, I again give it a role, and it is the same role. So it is a creative director for a TikTok account, and this video will be featured featuring tiny workers in whimsical miniature worlds, and so on and so on. And the task now is to analyze each scene in the context of the whole process and craft a detailed text-to-image prompt for our visualization team. Other AI agents for each step based on that information, and craft a short prompt for animation. So we want now to create not only text to image prompt, but also at this stage, we want it to have the whole context of a process and each step, and create a prompt for animation, create a prompt for sound effect, and also we wanted to give us an idea about background music. And then I ask it to output the result in this JSON format. Again, it needs to still keep that process in mind. So it keeps the process, it keeps, then the steps will be an array. So this is JSON format, and this square bracket indicates that there will be an array of those steps, more than one. And this is how you instruct it. Then for each step, we have a number, we have a description of that step. And then we ask our model to produce text to image prompt, animation prompt, and sound effect prompt for this one. So this is the block for scenes. And the process will be on the top level, and also at the top level we have background music prompt, because the background music is applied to the whole video, right? And we also give an example for text to image prompt. I found it works decently in this scenario. You can test multiple text to image tools, and I will also cover it a little bit later in this video, which tools I tested and which I ended up using. If you know how to prompt those models, you obviously will get better results. And I found that this prompt worked well for the tool that I'm going to use. So this is what I've done. And then in the user prompt, we get the process from before. So the previous step, once we parsed the result, we have the process idea and the whole process name. So this is the whole process. You just drag and drop in here. And this is the process ideas that come from the previous step. This is our result. Steps. Okay. So this is steps, and we just, again, drag and drop steps, and we need the whole JSON. So we, again, kind of back converted to JSON string. On the previous step, we converted JSON to object and took some parts from that object, and now we need only the JSON for steps. That's why we do the conversion back to JSON. And you can also, one important note is that by default you will see this prompt is at fixed mode, and you need to switch to expressions. And then once you switch to expressions, then you can click on this icon and it will give you an idea of how this will be populated. So in our case, because I have just run this whole workflow, I have the data from this workflow, and that was a miniature clockwork to assembly, and this is the step. So we again have step number, description for each step, and that is basically it. And after that, I also, in this case, I added an output parser. So I clicked require specific output format to make sure that we get always the output in the right format, that it is always contains scenes and so on, because we need it later. And in our structured output, I just pasted basically what we instructed the model to return right here. So this output, you can copy it and make sure that it is a valid JSON, and then you copy and paste it here in a structured output parser. It generates from, okay, we generate this from JSON example, and this is how we want it to work. We want to see a process, steps, and background music. Basically, that is what we have just seen. And on the right, we see the example of what it returns. This is how it works, and then we just parse. Okay, we don't need to parse those scenes because they were parsed here. So this time we set a new field, result, and the object is simple output from the previous step. And you see it here. You can get to JSON, and again, you drag and drop it here, and you'll see the result. What we do after that? So then I added two parts of workflow, and first one is a music agent, kind of an agent that, based on the background music description, it picks a music from our library. I try to find a way to generate music with AI, automatically. Unfortunately, I did not find a reliable way to create that music. If you have heard anything about AI generated music, then you probably have heard about Sono AI. Sono AI is a fantastic tool to generate music, also background music. You can generate music without words here and use it in your creations. But the problem is that it does not provide API by default, so it is hard to generate it automatically. I found this tool, sunoapi.org. It works decently, but I did not actually like the price. I found another tool, Kling AI. It claims also to produce music. I even topped up my balance and tried to generate a song with Suno. This says that it supports Suno and Udio. Okay, Music U. This is for Udio, and Music S for Sono AI. Unfortunately, I found that it does not work, and this service has been down for quite a long time. In any case, I could not find how to generate music. What I found worked for me in this case is that I found this, again, amazing competitor to Suno AI. This is an absolutely free project for now called Refusion. And I went to Claude. I asked Claude to generate me prompts for music for my TikTok movies in that style, and it came up with 20 ideas. Later, I copied those ideas and generated songs. As you can see now, I have 90 songs generated with Refusion. And then I had to listen them and create my own library of music. And after that, I went to my supabase. This is where you can use whatever you want. You can use Dropbox, you can use S3 storage if you have it. I found for myself that supabase is surprisingly useful for this case. Supabase has that storage function that not many people cover as well. So if you create a Supabase account, it is totally free. You go to storage, you can create a new bucket. In my case, I created this AI music bucket. I just uploaded all the music that I liked from Refusion, and then you can click on get URL and you get that URL. I also have a table inside Supabase where I store the URL to that music and a description. Actually, this is a description from Claude that I used to generate the music itself. So this is, I put the description, I put the music URL. It took it took some time to generate the music, but then it took maybe 10 minutes to compile that library of music. And now I have 21 tracks that I can use in my other creations. How you pick a music actually. This is a Supabase node. Supabase is connected to n8n automatically, and you create your own account with Supabase API. You connect it. Then we get rows from this table, shorts music that I showed you. This is my table, shorts music. So I select all the records. Currently I have 21. This is the records that I have there. Then I aggregate them into one field, into music tracks. We need only ID description, music URL. We don't need to create that is there by default. And then we have this as one object, and then we ask another language model. In this case, this is again a block with a system message and our musical process that we need. Basically, the system message says that it's a creative director, and then it needs to return a suitable music from our library for our existing movie, right? Then in movie, in user prompt, we specify what is the movie and what is the music that we want to find. So music is generated previously by our GPT-4o model, and process is this process. So we have another language model here. What to use in this case, it is Gemini 2.0 Flash, because it has longer context, and in case you have a lot of tracks in your music library, it will still be able to pick the right music. At the stage where you have only 20 or 50 tracks, you can use any other model and it will be perfectly fine as well. So it picks a music, and again, it outputs the ID and music URL. We need that music URL. next when we generate that movie. And finally, this step is just to store that return music URL. If you want to skip that step, you can also probably skip that step and don't include music, because, for example, some of the TikTok channels with viral videos that I saw, they don't use background music at all, and they still get a lot of attention. This is what happens to the music. Now we move on to what happens to our scenes, the most critical part of this workflow. So we set the scenes, right? And on this step, it is simple. Set block, and I set scenes. I basically get that array because at this point we don't need the process anymore, and we don't need to have that background music anymore. We are only interested in scenes. And then we split those out into multiple scenes. So instead of having it as a one object, we now have an object for each scene because we want to generate those scenes scene by scene. So you split it, and then here is an interesting step. Let's say you have 7 scenes like here. And if by default you don't have this block and you start generating an image, what happens is that all those 7 images will be generated all at once, but sometimes it takes a little bit more time, and we also have rate limits on many of those AI generators. In order to not stumble on those rate limits and have some of your images complete and some being discarded, then we need to have this loop over items. Here is how we add it. This is a loop over items, and split on batches. We actually need to split our scenes, our 7 scenes, into batches. And batch size in my case is 5. What it does is that it splits our 7 scenes in 5 scenes first and then 2 scenes, and it will process all those scenes in batches. And then once it's done, it will follow this done route, and we can again compile it all together after that. We split it into batches, and then the first batch begins. 5 scenes. I tested many different AI image generators. I tested Flux, Luma, Leonardo, freepik, Ideogram, Imagen 3 from Google, Midjourney as well. 2 tools that I found that worked the best for me were freepik and also Flux, but not Flux Dev, but Flux Pro. It worked very decently. You will see some images right here on the screen. Here you can see some examples from Luma. It is not terrible, but I found that it could not produce consistent images, and sometimes it didn't get my prompt right. And here are the results from freepik. To me, they seem to be the most compelling and the most interesting among the others. And what's good about freepik? If you go to freepik developers, you'll need to have your own account. They give you $5 in free credits, so you can generate first, I know how many images for free. And they have their own image model. What I found differentiates good videos from poor ones is that the quality of the image should be good. And if you generate something that is not good, then no one wants to watch it. freepik has their own model for image generation called Mystic, and you can see it in action here. I think that the quality is absolutely fantastic. You can generate images in 1K, 2K, or even 4K. Obviously, it will help you with the video quality as well. What I ended up using is just this 1K image, which I get by default. Okay, the default one is 2K, I use 1K. If I go to API reference, this is what you need to do when you generate an image from n8n. You go to developers, that API reference, and I used Mystic. You can also try other tools. You can also use Flux from here. But again, to me, Mystic worked the best. And here they provide you with the list of all those parameters which you can use. What I ended up using is style reference. We can see it here. This is the parameter that allows you to reference an image, and that image will be then used to affect all the images that you produce. What I did is that I found an image that I like. It is in white and blue shades. So all of the images that I now produce are within that same style. You can even get an image like that. You can generate one image manually. What you do next is that you go to that base 64 guru, because we need to convert that image to base 64. So I uploaded a file, and then I need to encode image to base 64. And you basically copy that base 64 and then generate an image in n8n. What you need here is that you need an authentication type. It is header auth, and then you need to add a new credential type. You copy your API key here. You send body. The body type is JSON, and we specify the body using JSON. Okay, using JSON. We copy that JSON. Actually, what you can do is you can go back here to Mystic, and you can copy this CURL. You copy it here. Okay, no, you need to copy data. You copy this data here, or you can copy the whole CURL, and then inside n8n you have the option to import CURL, and you just import it from there, and you'll have everything pre-filled for you apart from header auth for freepik. And then in JSON field, you already modify it. So the prompt comes from the previous step. In my case, this is loop over items. So when we loop, we have each scene, and this comes from text to image. However, what we need to do sometimes, that text to image prompt may contain quotation marks or any symbols that will break the JSON structure. So you need to do JSON and stringify. This is an internal n8n function that allows you to convert the string to the proper JSON string. This is what you do. You drag and drop this text to image here, and this is how it will work. For style reference, you copy the image from this base 64. If you are not sure, you can again copy this base 64 image, and here is another base 64 to image conversion happens here. You go there, you copy your base 64, you decode base 64 to image. This is the image that I decoded, and it lets me know that the base 64 is correct. Next, you have this one, image reference, and the rest of the details. Then when you do it, what happens is that it takes quite some time to generate an image. It may take 20 seconds, 30 seconds, 40 seconds. Actually, you never know when this will happen. There are some limitations, but obviously some things may go wrong, and you cannot be just sure that in 60 seconds this image is generated. What n8n is good with is that you can loop and constantly check the status of the image generation process. So after you ask to generate an image, we wait here for 20 seconds, and then we check if that image is generated. So I make an API call. It is again here. You can go back to freepik, to developer docs, and see that there is a way to get the status of the Mystic task. This is the task. You again can copy CURL and copy it into this HTTP block. Yeah, this is the basic HTTP block because there is no integration in n8n for freepik. You use HTTP blocks instead. And in this one, we check the status of the image, and we need to have the ID, and the ID comes from the previous step. Even when we wait for 20 seconds, you see we have a task ID, and we also this one was generated, but for example, this one was in progress, and we have the task ID, and you need drag and drop this task ID here. This is exactly what it needs to know. You can even preview the result. And we do the get request, and once we see what it generates, both images were completed. This is from my last run. And you get URL to the generated image. You can preview it here. This is the image. It is crisp, it is sharp, it is good enough to be used later for animation. Once you wait for 20 seconds, you need to verify that the image is actually completed. And what I wanted to achieve here is that we want to wait until all those 5 images are actually processed before we move on to the next step, to the animation, because if one of the images is stuck somewhere, then we don't actually need to generate animations too, right? How you achieve it is that we add that if block, and inside if block we check that the status of the all 5 images is completed, or just it is not in progress in this case. And so inside if block we get input all, so it will be 5 images or 2 images, because we process 7 images. I hope it's clear. So we check that all the images that came to this block, that all of them have the status, in this case, that there are no more images that are in progress stage. And we do a little bit of JSON here. Again, you need to switch to expression. We check that all of those images are not in progress, and so the length of the images that are in progress is equals to 0. And another condition is just a fallback scenario. If this whole loop has already been run for 50 times, then it will exit. It is not a necessary condition, but it is just here as a fallback. And once all 5 images in the first run, if we split it to 5 and 2, when first 5 images are being processed, then we set the scenes, and you will get the URL to your image right here. And 2 more things that I added: the scene number and also the animation prompt. And once we get those 5 complete, then we move on to video generation. Video generation is also another funny part. I have tried other tools. I have tried Google VO2, Kling AI, Minimax, Luma, Ray, and Runway. Obviously, I don't want to spend a fortune on generating those videos because I don't know if they will work, if they do not work, and I wanted to find something that will strike a balance between cost and quality. And obviously, we also need something that can generate images via API, via our automation from n8n. And there are actually quite limited possibilities for that. If you go to Luma AI, this is one of the tools that I wanted to use. And if you go to pricing, you will see that in order to generate RAY 2 image, it starts from 24 cents per video, per 5 seconds, but it is only for, I think that this is for RAY 2 Flash. And when I tried to use RAY 2 Flash, it did not produce the result that I expected. You can see it right now, what it produced. So it generates a very simple animation, which does not suit the overall video idea. And RAY 2 is more expensive, and even when I tried RAY 2, it also did not produce the result that I expected. This was one of the possibilities. If you try to use Google VO2, it is even more expensive. It is 50 cents per second. And then in order to generate a 30-second video, how much do you need? $15, am I right? Yeah, $15, which is a lot for this short video, depending obviously on your goals. Maybe you sell a product and this price is no-brainer for you, but in my case, I did not want to use this one. Runway is very similar. You pay 25 cents per 5-second video. It is nice, but again, it depends on what you want, and this is not even for, I believe this is only for Gen 3 and not for Gen 4. Okay, you may check and maybe you will find that something else works best for you. What I found is that I decided to use Faceless AI, and it has some problems today, but overall I decided to use Kling, and here I use Kling Video 1.6 standard image to video. This one, it costs 3 cents per second in comparison to 50 cents per second from Google VO2. I think this one is no-brainer, and as you can see on this screen, it obviously produces one of the nicest animations among all of them. I have already spent quite some money on that model and on generated multiple videos. You see all of them are in the same style. There are some occasional videos that do not fit our style, but anyway, for example, those ones, they are again super nice, and they fit perfectly to that type of scenes that we want to produce. And as you can see, the quality of the video is good, the animation is good as well, or this one, for example. So for me, Kling turned to be the model with the best ratio between price and quality. And that is what I use to produce the videos that I showed you. So now we need to do that Kling integration, and how you do it is that you go to File AI, you need to have your GitHub account to register here. You go to API, and this is Kling Video v16 standard. Make sure that you pick the standard one because the pro one is much more expensive. And then you go here to API documentation. You can see what you need. Again, you can see that CURL command. However, you cannot just copy it from here and post it to n8n because it has those additional request ID and response. You need to copy from here, from CURL to here, and copy this part into n8n, into this block, into HTTP. So you import CURL and then you get all the parameters. So here we do the post request to File AI, to this model, to Kling, for image to video, and we reference image from the previous step. We send body, we send JSON body, we get prompt. The prompt we get from the previous step because we just set it. Then we set the image URL. We also get it from freepik. Then aspect ratio is 9:16. And this is the scale. I don't even remember what it means, sorry, but you can go here and read through all those parameters. Scale, measure how close you want the model to stick to the prompt. Okay, the default was one was 0.5. I set it to 0.8 for it to better follow the prompt, I guess. After you send that request, you get the status of your task. It is first goes to in queue, then it goes to in progress, and then it can fail or it can succeed. We have the similar problem to the previous one, so we want to make sure that all videos are rendered before we proceed, because there is no sense if one video is in the scene is not rendered, then what is the point in rendering the whole video? And again, we don't know how long it will take. It may take 100 seconds, it can take 200 seconds. I saw a huge variation in those values of how long it takes to complete the video. So what I do here is that I set another wait timer for 30 seconds, and each 30 seconds I check what is the status of all our videos that are currently in progress. And File AI has a limitation. It allows you to simultaneously process only 5 videos. That is actually why I set 5 as a batch size here. And so we process 5 images at a time right here. Again, we check the status. For status, we have even a status URL that is returned back from File AI. We need to use that status URL from here. We do a GET request to that status URL with, again, the header auth from File AI. And you will get as a response something like that with the status. And if it was successful, then we again need to make one more request to fetch the video itself. But before it, we do exactly the same thing as before. We set an if module and we check that current status, if current status is in progress or in queue, and we need to make sure that there are no elements that are in progress or in queue before we move forward. And again, as a fallback, we set that if run the index, if currently this loop has been run for 50 times, then we exit, but make sure that this value is high enough and it allows you to process all the videos. After this condition is satisfied, after there are no more elements that are in queue, then we get the video. This is get video. We can get the response URL. Previously we checked status URL, now we get response URL. We check it with the same header auth parameters for File AI, and we get the link to the final video, for example, this one. Okay, this is the final video that was generated, and we have got all 5 or already 7 of them. One more step here to set the video ID, sorry, video URL. and scene number. Let's go back to our drawing board. So we generated an image and we generated an animation, and in parallel we can generate a sound effect for the background music. We have two paths that exit this loop over items. The first one is responsible for generating an image and video, and second one is responsible for generating the soundtrack. For soundtrack, we already have text to soundtrack prompt. So we go to ElevenLabs and we use ElevenLabs to generate that sound effect. It has the sound generation API. And if you go to API reference for ElevenLabs, here we have sound effects right there. You can generate a sound effect for your scenes. It can range anywhere from 0 to 0.1 to 30 seconds, and it is relatively cheap to generate those. If you go again to developer quick start, you need to have your ElevenLabs API key. I'm sure you can find how to do that, and we need a C URL again. Okay, you need to go here to API reference and then to sound effects, create sound effect, and you can copy it again from here, from C URL to n8n to generate your sound effect. This is the post method for a sound generation URL, and the text comes from our step from here, sound effect prompt, right? The duration, I set the duration to 8 seconds. Our video will be 5 seconds by default, but I found that setting a little bit longer duration for a sound effect works better than generating the sound effect that is exactly 5 seconds, because believe me, it will work better. And prompt influence is close to 1 for our model to follow the prompt. We don't want to have surprises here. Then you can listen to the generated music. Right here, you don't need to wait until the generation is done. It happens almost instantly. After that, you get the file, and we actually, in order to render the whole movie, we need to have a URL to that sound instead of having that sound itself. In order to get that URL, you can upload that sound effect to anywhere. I use supabase for that as well. And here is my connection to supabase. Supabase has an API for storage. It was hard to find, but you basically specify storage object, and then here is the path to your storage, and then you set the name of the file, and you need to add the extension to that file. This is the post method, and you need to authenticate your supabase account, send body, and then we send actually the data that we have here. So this is the data that we get. If you view it, you can hear the sound, okay? And we want to upload that to the supabase. If I go to supabase, to my storage, to my content automation, I have ElevenLabs folder, and these are the sounds that were generated from ElevenLabs. And then we want to generate the URL to that file. By default, it uses the connection to your supabase, and then you need to make sure that this is a public repo and anyone can access it. And we just want to make sure that this file is accessible. Okay, here is the file, it works. And finally, after each scene is done, we want to combine the scenes. Later, we'll be using JSON to video to generate the scenes. So now we want to make sure that we prepare the structure for it. How to do it is I use another set module and already generated JSON for our file. So I set the ID for a scene. It doesn't matter which ID you use. I use scene, elements, ID type, source for our video, and this will be the video URL, and then we also need a sound. So each scene has a video and background sound. This is what we want to render. And then for sound, it will be the link to this file, audio, comment. It actually doesn't matter. The volume, yeah, I also set the volume to be half of the volume that ElevenLabs produces. Otherwise, it is too loud, and duration is -2, which means that the length of the sound will be adjusted to the length of the video. That is why we don't care if the sound that we generated is 8 seconds or more. It anyway will be adjusted to the length of the video itself. this is a structure that comes from JSON to video tool, and as an output, you can see we have all those scenes. And after all the scenes are being rendered, then I add another aggregate block. This is the aggregate, combine a field from many items into a single line. As you see, 7 items entered this block and only 1 item left this block. So we made something to those 7 items. We combined them to scenes because I preset this scene JSON after the merge. Yeah, by the way, the merge is important. We need to combine matching fields by scene number. At this time, if you remember, we generated the music in one route, and then we generated the video in another route, and now we need to combine them. Because we want to combine them, by scene number. Output is keep matches, so we want to make sure that we have the video, the scene, and the sound for each scene. Okay, and because we set a JSON to video structure there, we don't need to worry about the structure in this block. We just output it in a field called scenes. This is also important, and we put all the fields basically there. And at this point, we have all the scenes right here. Scene 0, scene 1, scene 2, 3, and so on till scene 6, and we start from 0. Then we do this again. We merge 2 items. At this point, we have all the scenes, and we also have selected the background music from our library. So we want to combine them all into one big object. And finally, we want to prepare the final structure and render our video. This is the tool that we want to use. This is JSON to video, and you can go and create a new template. This is how I would recommend you to start using this tool. So I created a new template, and in a template, I basically have multiple scenes. I have also a movie element, and I also wanted to add my watermark because those videos can be copied, and probably you don't want anyone else to copy the videos that you produce. This is the easiest way to preview how JSON to video will generate a video. So you add some scenes here. We have, again, just video and a sound. This is one of the videos that I produced. I also like this one. Another video, another sound, and it will just repeat multiple times, but it will allow you to understand how it will all works together. And then the final, okay, those were the scenes, and then the final element is our background audio, and the watermark is also here. Then you can go to JSON, no, not here, to the whole movie. You pick the whole movie and go to JSON, and you will see the JSON right here. You can obviously use JSON to videos API with this JSON to render this video. As you can see, they use ID in that same style that I use. I mean, I use the same style that they use for IDs. And comment resolution, you see all of the items that I needed here. You can set up your watermark and make it a little bit different to your liking. I used this JSON as an inspiration for my structure. I copied it and modified it then inside n8n. This is the final JSON that we want to use to render the video. Again, ID, comment, resolution, it closely resembles what I have got from this screen with this JSON. And we set quality to high, resolution custom, a full movie. Yeah, we then set this resolution to 720 by 1280. And our elements are audio, the main music audio. The duration is -2. It shows that the duration of the audio will be matched to the duration of our scenes. So it doesn't matter if the whole soundtrack is 1 minute, but the video is only 30 seconds, it will be truncated to the 30 seconds. Then we have scenes, and scenes come from the previous JSON because we have already formed that one, and this element is actually the watermark. And this is the final JSON that we get. If you don't know if it's right or not, you can copy it and go to JSON to video here inside the template. You can edit templates JSON, yeah, and you can actually paste the JSON here and see what it produces. And then we use the same pattern. The rendering takes quite some time. We wait here for 10 seconds, and then we check the status of the render. This is where we need to provide our project ID, which we get from the previous step, from when we asked JSON to video render our movie. It gives us project ID, and then we use that project ID to check the status of our project. Again, you need to add your header auth in JSON to video. You have your API key. Here is where you get your API key. You enter it in header auth, and then this is a simple GET request. Then we can check if the status is running. If it is not running, which means it is complete, then we get the file using the URL from previous step. When we checked what is the status, we get the movie URL, and you actually can even view or download this file right here. And as a final step, you can perfectly use it from here and download the file from here, or in my case, I uploaded to my supabase. Similarly to how I uploaded background sound effect, I upload the video to just another folder. This is the post request to my supabase with that n8n binary file with data from binary file. This is it. This is quite a robust system. You also want to make sure that, for example, here you go to settings and you set the retry on fail, because sometimes those blocks fail, and I wouldn't claim and say that it works perfectly. Sometimes it breaks. It breaks when some of those services go out of service. For example, File AI bugged me today and they returned an error. It was not related to this flow, it was related to their internal service. And sometimes it still may happen that some things do not work properly. But I believe that this is a very solid workflow, and it addresses a lot of other issues that were not covered by other tutorials, so I hope you enjoyed it. A couple of final words about the cost of the video. So you pay for Kling AI, the cost is 3 cents per second. So for 1 minute long video, you need to pay around $1.8. Then you also need to pay for JSON to video for rendering. I use it on a pay-per-use basis. I bought credits once and now I use them. I believe I have a lot, even if it doesn't render. Yeah, I topped up it by 120 minutes. It should be enough for you to generate a lot of those videos. And also you need to pay for API for freepik for Mystic image. And the cost to generate it is just 6 cents. So for, I don't know, for 10 images, it will be 60 cents. And overall for 1 minute video, the price will come down to around 2.2, 2.3, along those lines. But if you are serious about it, I believe it is still much faster than doing everything manually. This is actually the best way to generate those videos that I have found. There are some ways. I will not lie to you and say that there is only one way to do it. You can achieve the same results with many other different tools. By using different methods. You can even use some open source models to produce music or to generate images or videos. You can run it locally. The choice is yours. This is just one way to generate those images. Thank you for watching. This template took quite some time to build and explain. You can definitely build it on your own, but if you want to save some time and start from a ready-to-use template, then you will be able to download it for a small fee by using the link below. And if you have questions, then also let me know, and you can also connect with me on LinkedIn, where I post a little bit more frequently than on YouTube. Thank you so much for watching, and see you in the next video. If you have any ideas, also please let me know.